Hi, welcome to Send to Print. Today we're going to model a twist snap mechanism. It can be used for twist snap containers, or we can use it to join the lampshade and base from our last video. This tutorial is a bit longer than usual because we're going deep, not just on the mechanism itself, but also on adding cooling holes and cable management to create a truly functional lamp base. I'll also break down the difference between paste and paste new and show you how to build the as-built joint to get it all moving. Okay, let's dive straight in. First, let's take a look at the design. The plan is to place the LED directly on the base. I'm using a 2 mm wall thickness here, and this is where the shade goes with a 10 mm thickness. So the total shade diameter will be the LED diameter plus 24. Now we'll input these into the parameter table, which makes it super easy to adjust everything later. Go to the Modify panel and select Change Parameters. Click the plus icon to add our first one, light diameter. Let's set it to 30 mm. Next, we add wire diameter set to 2 mm. And the last one, the shade diameter, input light diameter plus 24. To better manage our resources, let's start by right-clicking the root component in the browser and select New Component, name it Base. Create a sketch on the XY plane. Press C for circle, snap to the origin, then type in light diameter. We'll offset this circle, 2 mm for the LED wall, another 2 mm for the interface, and one last offset of 10 mm for the lampshade. Finish the sketch and rename it to Base. Trust me, naming your sketches is a great habit. Spending 1 minute here will save you tons of time later. Hit E to extrude. Select the entire circle. Pull it up by 8 mm. Now, turn that sketch back on and use E to extrude again. Select this ring this time. Pull it up by 16 mm and set the operation to join. This is our base body. Let's rename it to base. Now we'll create a new component to hold the lampshade and its connector. Right-click the root component in the browser and select New Component. Rename it to Lampshade. Hit E again, but this time, select this middle ring, set the start to object, and pick the top face of the base. Extrude up by 8 mm with the new body operation. Okay, let's rename it to Fitting. To get a better look at the model, let's go to the Inspect menu and select Section Analysis. Pick the XZ plane as our reference. If you don't see anything, just click Flip. Right now, these two parts are just sitting face to face. Next, we're going to build the actual twist snap mechanism. Before we go any further, let's see how this twist snap mechanism actually works. First, we have a radial lug on the base part. During installation, you align this lug with the entry slot. Since the slot is slightly wider, it slides right in. Then, as you rotate, the lug follows a curved path until you hit a tiny bump, a detent. With a little extra force, the plastic flexes just enough to let the lug snap over it. The moment the lug snaps past that point, you'll get clear tactile feedback. That's the click sound we're looking for. Once the lug snaps into the locking zone, there's a much higher hard stop wall right in front of it. This wall is too high to be pressed over with normal force, so the lug can't rotate any further, effectively locking it in place. All right, I'll keep this diagram on the side as a reference, and let's start building it by creating the lug. Create a sketch on the top face of the base body. Use shortcut P to project the outer edge. Now offset the outer circle by 1 mm. Draw a line from the origin and mirror it across the y-axis. I'm using the shortcut D to set the angle to 30 degrees. Okay, here is our little lug. Now, everything looks fully defined. Okay, let's finish the sketch and rename it to lug. Hit E to extrude this profile. Set start to offset, -1 millimeters, and the distance to 4 millimeters. This is our lug height. Set it to join so it merges with the base. To avoid overhang issues, I'm using the chamfer tool to these two edges. Give it 1 millimeter chamfer. Okay. Now, switch over to the lampshade component in the browser. We're going to cut a groove into the fitting body. Let's use the revolve tool. Hide the body for now, so we can pick the side of the lug as the revolve profile. And pick the Z-axis as the revolving center. Set it to full and operation to cut. Just be careful here. Don't forget to hide the base component first so we don't accidentally cut the lug itself. The lug has room to move now, but it needs an entry slot to get started. Plus, we're still missing the hard stop here and the detent right here. Create a new sketch on this face. Hit P to project the groove. Hit P again, show the base again. And project the top face of that lug as well. We need these projection lines as our reference. We'll draw the entry slot and the hard stop first. Draw 3 lines from the center. This point is the hard stop. Here is the tangent point of the entry slot, and this is the end of the entry path. Use shortcut X to make this one to a construction line. Use shortcut D to set this angle to 15, and this one to 45 degrees. Now, let's draw an arc using the center point arc tool. And use a coincident constraint here. Since our lug is 30 degrees, this 45-degree opening is plenty of room. Next, we're going to draw the detent. Draw a line from the center to the edge. Then use the center point arc to snap to the center and draw a short arc. Make it coincident with this line. Then hit D for dimension. Set the width to 2 millimeters and the height to 0.4 millimeters. This height value is key. If the detent is too low, it'll twist in too easily, but it might be too loose to stay locked. If it's too high, it'll be hard to twist. You might need way too much force, or it might not clear at all. Based on my testing, 0.4 works just fine, but you can always adjust this to fit your own project. Before finishing, check for that small lock icon. It means it's fully constrained. If your lines are still blue, they're under constrained. We want this logic to be rock solid, so it won't break when you adjust parameters later. Okay, let's finish the sketch and rename it to Twist Snap. Now, hit shortcut E to cut the entry slot. Select this profile, toggle the body back on, set the extend type to object, and select this face. Make sure the operation is cut and the base body is hidden so it won't be cut by accident. Okay, now our lug can enter the groove from here. To add the detent and the hard stop wall, let's hit shortcut E to extrude again. Select the small bump and the end profile. Set the start to object, select the top face, and use join. Now we've got a working twist snap. But if we stop here with just one single lug, we're asking for trouble. Think about it. The entire weight of the shade and all that torque you apply when twisting it on would be concentrated on one tiny point. That lug would basically act like a pivot, making the whole shade tilt and wobble, and after a few uses, it's probably just going to snap off. To fix that, we need to balance the load. Let's head up to Create, then Pattern, and grab the Circular Pattern tool. Make sure your object type is set to Features, because we want to grab those specific steps from our timeline. The steps that create the entry slot, the hard stop, and the detent. Pick the Z-axis as your center. And set the quantity to 2. Just like that, we've doubled our strength. Now, instead of one point taking all the stress, the load is perfectly distributed. To get a better look at the twist snap mechanism, let's go to the Inspect menu and select Section Analysis. Pick the XY plane and drag it up. For a lightweight project like this, 2 lugs are plenty. It's clean, symmetrical, and gets the job done. Of course, you could always crank up the quantity in that circular pattern to 3 or 4, but honestly, 2 is just enough. Now, let's add some utility features. We'll start by sketching the cooling holes. Hit P to project that inner wall so we know our boundaries, then hide the body to clear the clutter. Hit shortcut Q to offset it inward by 2 millimeters. Grab the rectangle tool, specifically the center rectangle, snapping it right to the origin. And hit D to set the height to 6 millimeters. Check if it is fully defined here, the small lock icon. Okay, finish the sketch and rename it to cooling holes. Next, hit E for extrude and select those 2 semicircles. Set your extend type to all. If nothing happens, just click the flip button. Also, make sure the operation is set to cut. Hit OK, and there we go. 2 vents to keep things cool. To give it a more finished, professional look, hit shortcut F to use the fillet tool and add a 3 millimeters radius to these sharp base corners. Now, we need some space for the power cable. Create a new sketch on this side face. Instead of a circle, we're going with a circumscribed polygon. Why? Because when 3D printing, the circular holes always sag at the top, and polygon gives us a much cleaner bridge, so the cable actually fits. I'm drawing an octagon here and adding a horizontal constraint to this edge. Here is a tiny bridge, and since this edge sits at a 45-degree angle, we won't have any overhang issues to worry about. Draw a construction line from the center of this edge to the origin and lock it to vertical. Sketch out the rest of the profile. You may wonder why adding this tiny protrusion. I'll explain why in a second. Let's mirror everything to the other side. And hit D to get the dimensions right. Set the size to wire diameter plus 0.2. 0.5 millimeters for the gap. Here, a height of 3 millimeters. And 0.2 for the bump width. We want the bottom a bit wider so the cable slides in easily. That little bump is there, so you have to give it a tiny push to snap it in. That way the cable doesn't just fall out when you move the lamp. Finally, I'm using the shortcut X to turn these two lines into construction lines, so it'll be easier to select the profile later. Now it's fully defined. Okay, let's finish the sketch and rename it to cable hole. Now, hit shortcut E, grab the profile, set it to all, flip the direction if you need to, and make sure it's a cut. And that's cable management done. For the final touch, we'll get to tolerances. We need a bit of breathing room for the base and lampshade to actually fit. Grab the offset face tool or hit shortcut Q. Select the lug and the mating surfaces and enter negative 0.1 millimeters. Do the same for the base where the LED sits, also a negative 1 tolerance. Then hit F for fillet. Add a 0.5 millimeters fillet to the lug edges to make it glide easily in that groove. Use fillet again. Add a tiny 0.2 millimeters radius to the detent to help the lug glide over the bump. And just like that, our twist snap mechanism is finished. Let's see if it works. Go to Assemble, select As-Built Joint, and pick the base and the lampshade. Set the motion to revolute and pick your center axis. Now try drag the fitting body. If it's acting stubborn, just go to the Select menu and make sure Component Drag is toggled on. As you rotate, the lug follows the groove until it hits a small bump. With a little extra force, it snaps right over that detent with a satisfying click. Now it's in the locking zone, stopped by a higher wall and locked perfectly into place. It works just as we expected. Finally, let's bring in the twisted lampshade we made in the last video. Copy the component and right-click. Make sure to select Paste New. Here's the deal. A regular paste creates a linked instance, so if you change one, you change them all. But Paste New gives us a completely independent copy. If you missed our last video, no worries, you can just start a new component, follow that tutorial, and model the shade from scratch right here. Okay, back to our modeling. Now, inside this component, we have our connector fitting and the lampshade subcomponent. Together, they make a perfect one-piece parametric lampshade with a built-in twist lock. You may also notice that we haven't merged all the separate bodies, but don't worry, this won't affect the print at all. Sending these independent bodies to your printer works perfectly fine, as long as you don't manually split them in the slicer. Wait a second, look at here. There's a mismatch between the base and the lampshade. If we head back into the parameter table, you'll notice some new parameters has popped up. That's just the parameters that came along with the component we just pasted. To make sure the base and the shade stay perfectly in sync, we're going to drive this new diameter 1 parameter using our shade diameter variable. Just type it in and they're locked together. And I'm deleting the new light diameter 1 parameter since we're not going to use it anymore. Now they're perfectly aligned, and they'll stay that way even if we change the parameters later. Let's take another look with the section analysis. If we zoom in here, you can see the inner wall of the shade is actually crashing into our connector's internal structure. It's a bit of a mess, so let's clean that up. Turn that sketch back on. Hit E to extrude. Select these profiles, and for the extend type, set it to object. Pick the top face of the fitting body, and don't forget to hide the fitting body now so we don't accidentally cut into it. Make sure the operation is set to cut, so we're only trimming the shade bodies. Okay, let's bring our fitting body back on. It looks all right now. Just like that, we've built a fully functional parametric lampshade with a built-in twist snap interface. Now I'll input the actual size of my LED. Open the parameter table, change the light diameter to 60 millimeters, and the wire diameter to 2.8 millimeters. I just measured it with calipers. It's looking a bit short, so I'll just bump the height up to 200. Everything scales perfectly without breaking a single feature. Now, all that's left is to export these two components and send them to the printer. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. Here's the final print. I've already printed the full lampshade in the last video, so I only printed a small section of the shade this time to quickly verify the mechanism. Let's look at the base first. Here are the cooling holes and the cable port. Let me slide the wire in and seat the LED. Give the cable a little push to snap it into this slot. Now you can see, even with a bit of a pull, that wire isn't going anywhere, so no more annoying cables falling out. Now here's the shade, well, a small section of it. For the assembly, align the lug with the entry slot. And rotate. Right here, I'm feeling a bit of resistance. That's our detent. Give it a tiny bit of force, and with a satisfying click, it locks right into place. Let's see it with the light on. Now I'm actually regretting not printing the full shade. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.